Legend has it that a man named Isaac Newton was sitting under an apple tree when he got bonked in the head with an apple. He realized that some type of force must have been acting on the apple to make it move from rest, and he named that force gravity. Soon after, Newton created one of the most fundamental laws of physics, the universal law of gravitation, which describes the characteristics of gravity. For over 200 years, Newton's laws and theories on gravity were used by scientists all around the world. However, there remained a mystery. Where in the world did this mysterious force of gravity even come from? And that's where general relativity comes into the picture. In special relativity, a super smart genius named Albert Einstein fused the three-dimensional aspect of space and the one-dimensional aspect of time into a four-dimensional space called the space-time continuum. In general relativity, Einstein speculated that gravity is formed when large objects curve the fabric of space-time. If you place a large object on a trampoline, it would create a dent, and if you dropped a smaller object, it would roll around the bigger object. That explains planetary motion, but most importantly, gravity. General relativity states that warp space-time is what keeps our feet to the ground. Einstein's field equations are a bunch of 10 equations in one explaining general relativity. They involve tensors, matrices, other crazy mathematical concepts, and takes years of physics to fully understand it. However, theoretical physicist John Wheeler summed up Einstein's field equations perfectly. Matter tells spacetime how to curve, spacetime tells matter how to move. The left side of the equation explains the curvature of spacetime, while the right side of the equation describes the movement of matter through curved spacetime. And that's general relativity. But it doesn't end there. Einstein used general relativity to predict the existence of gravitational waves, which are ripples in spacetime caused by accelerating objects. In September 2015, the Laser Interferometer Gravitational Wave Observatory, better known as LIGO, detected the first gravitational wave almost a century after Einstein predicted them. They used a laser interferometer to discover the existence of gravitational waves. But how do these devices even work? First, a laser emits light that hits a beam splitter, dividing the light in two. Next, each light beam bounces between two mirrors, forming a perpendicular line. A passing gravitational wave causes the length of the arms to change, which is detected by a photodetector. Not only did Einstein solve the mystery on gravity, but he detected gravitational waves and changed the course of physics forever.